So it is officially day 12 out of 15. That's crazy. It's just going by fast. And it is Monday, June 16th. And for your do now today, I gave you a few different quadrilaterals to find the area and the perimeter of. And then I gave you a little challenge question, if anybody could figure it out, for finding the area and perimeter of a triangle. So this one we did not specifically go over yet, but I just thought I'd see if anybody could figure that out. So for number one, first of all, do we know what kind of shape this is? What would the name of this shape be? Yes, Titania. That's okay.
I got it, but it is a parallelogram.
Yes, this is a parallelogram. We have opposite sides that are equal and parallel. Yeah, it's a parallelogram. That's as specific as we can get with it. And the first thing I asked was for the area. So which numbers that are labeled here on this parallelogram are we going to use to find area? Go ahead, you can continue.
12.5 times 8 inches.
Yes. So we're going to use the 12.5, which is our base, B for base, and the 8 inches, that's our height, H for height. Okay, so is there a reason that we're not going to use the 9.2 for area?
Because that's your perimeter.
Yeah, because that's going to help us more out with the perimeter. This is a side length, and it doesn't tell us how tall the shape is. It's just giving us the length of that side. So what am I going to do with those two numbers?
You're going to times them.
I'm going to times them. I'm going to multiply. So let's see, 12.5, I'm going to write over here, A equals, so area, 12.5 times 8, and what did you get?
You're going to get 10.2 inches squared.
10.2? I feel like that should be a bigger number.
I might have mixed it up.
That's okay. Yeah, try typing it again. Let's see what we get. I'm going to grab my calculator too. 12.5 times 8. Let's see. 12.
100 inches squared.
Ah, okay. So 12.5 times 8. Let's see. And wow, yeah, it's an even 100. I wasn't expecting that.
I put the dot in the wrong spot. So
That's okay.
it's 100.
That's okay. So the area is 100, and I love that you also gave the correct units, inches squared. So for area, we got 100 inches squared, because area is base times height. Okay. How about perimeter? How do we do that? Does anybody want to guide me through perimeter? Amanda?
You're going to take, well, the way I did it is it's going to be all the 12.5 times 2.
Oh, yeah. 12.5 times 2. Now, why are you taking that 12.5 times 2?
Because you want to, because the one on top is going to be also 12.5.
Yes, yes. So Amanda said we needed to use 12.5, but we need to take it times 2 because this side is 12.5, but with the 2 tick marks, it tells me that it's also equal to the side on top. Both of those are 12.5. So we're going to start, you said 12.5 times 2, and then what'd you do?
And then 9.2 times 2.
Yes, and then the other two sides, 9.2 times 2, because this one is also 9.2.
To make it in more simpler terms, you're just going to add 12.5 plus 12.5 plus 9.2 plus 9.2.
Perfect. So you're just adding 12.5, 12.5, 9.2, 9.2. And let's see. I'm going to do 12.5 times 2. Yeah, that gave me 25 right here. So I might be doing it slightly different than you did.
Yeah, it's a long day.
This is a little bit longer, I think. 9.2 times 2. I got 18.4. And then we add those. Plus 42.4?
Yep.
Somehow I got 43.4.
I got 43.4.
Huh.
I might have typed it wrong too.
Oh, that's okay. I got 43.4. Let me try doing it the way that you did, where you just added the 4 numbers together. So 12.5 plus 12.5 plus 9.2 plus 9.2. I still got 43.4.
Yeah, I got it done.
Perfect, perfect, perfect. Okay, so 43.4 would be our perimeter, and what are the units? Inches. Good. So there's a lot of different ways to find perimeter. You could add all those side lengths together. You could say, well, I know there's 2 sides that are 12.5, so I could take that times 2 and add that to 9.2 times 2. Or you could use the perimeter formula, which I'll write it up here. Remember, that's where we take perimeter equals 2 times its base plus the side, which is just the most condensed version of that. But you're really just adding the 4 sides together. Okay, before we go to number 2, do we have any questions about how we got these answers for number 1? Does everybody understand that pretty well? Okay, I see heads nodding. That's good. Okay, let's look at number 2 then. Number 2, what kind of shape is this? It is a square. Now, if I wanted to get really, really, really technical, since I didn't mark my 90-degree angles, we don't know for sure it's a square, but it really looks like a square, so I'm going to tell you it is a square. But, you know, the angles could have been different. So this is a square, and how am I going to find the area of this square? I know you know it. Who wants to tell me how to find the area? Lisa, tell me about it. What's on top? Yes, the top side length is also 13.7. What else do we know? Yeah, it's going to be the same on the other sides. How do you know that all 4 sides are going to be the same? There's something telling you that. They're all the same. There's a little marking that tells us. Technically this, yes, you're correct. This is the height. What I was looking for is these little tick marks. Since they all have 1, it means they're all the same. Okay, so how would we use that to find the area? You're going to times these? Perfect. So for area, remember we're taking the base times the height. In this case, our base here at the bottom is 13.7. And the height is here on the side. It's also 13.7. So we're going to multiply those. 13.7 times 13.7. And what will that give us? Let's see, I'll type it into 13.7 times 13.7. I got 187.69. Did you get the same thing? Nice, nice, nice. Okay, so our area would be 187.69. And what would our units be? Inches squared. So 187.69 inches squared. Good.
I'm sorry, how'd you get that again?
So we took the base, the 13.7, times the height, also 13.7. And we knew that these were all 13.7 because they all have the same one tick mark.
You just added them all together.
So if I added them all together, I would get my perimeter. For area, I multiplied them. I did 13.7 times 13.7 because that's the base and it's also the height.
Okay.
Yes. Now with a square, there's also a special area formula, and it's super easy because it's like one letter. So if you're curious about that, because a square has all four sides the same, another way to do the area is to say our side length, we'll name it as S. So this could also be called S because all the sides are the same, squared. So I could take 13.7 squared in my calculator and get that same number, and I'll show you that. Here. 13.7 squared, enter. Kind of cool, because remember, squared just means taking that number times itself, and that's what we just did. Another way to do it. Yeah. Okay, so we've got that. Now, how would I find the perimeter?
Did you add?
Add. Yes, what will I add?
13.7 plus 13.7.
Okay, 13.7 plus 13.7, that's two sides.
You'll make it
27.4. Okay, so that's two of my sides. Does that give me the whole perimeter? What else do I need? I'm going to do the same thing again. 13.7, 13.7. That gives me 27.4 again. And then I'm going to add these together. So you're going to see again, there are so many ways to find perimeter. You can do it like this. Squares have a special way to do it, and I'll show you that in a minute. Yeah. 27.4 plus 27.4. And Lisa, what did you get when you added those? Okay, well here, we can do it together. 4 plus 4 is 8. Bring down my decimal. 7 and 7 is 14. Carry my 1. 2 plus 2 is 4, 5. I got 54.8. Is that what everybody else got?
Yes.
Perfect. Okay, so the perimeter is 54.8. What's my units? Inches. IN. Good. And I'll kind of circle these so it's easier to see. That way it's separate from all the work. And I'm going to also write this down. Another trick for finding perimeter, because all we did was take that 13.7 and add it to itself 4 times. Multiplication is repeated addition. If I say I want 3 times 4, that's really the same as 3 plus 3 plus 3 plus 3. So 13.7 plus 13.7 plus 13.7 plus 13.7 is the same as 13.7 times 4. And that would give me my perimeter as well. But that only works if all 4 sides are the same. Okay. That's number 2. Do we have any questions about that one? You ready for 3? Number 3. Okay, number 3, what kind of shape is this? Rectangle. Good. Good. So, with a rectangle, how will I find the area? Titania?
You take 53.2 times 23.1.
Perfect. 53.2. That's my base. I'm going to write that over here. 53.2 times my height, 23.1. And what do we get?
1,228.92 inches squared.
Woo! I'm going to have to type that one in. That's a lot of numbers. 53.2 times 23.1. And we do get that very large. Let's see. 1,228.92. So let me write that in. 1,228.92 inches squared. Good. Okay. Everybody get that one? Now, at any point that we're doing these, if you got a different number or you're not sure how we get a number, let me know so we can talk about it. I do want to make sure we're all understanding. Okay. Perimeter. How do I do that one?
You take 53.2 plus 53.2
Mm-hmm.
plus 23.1 plus 23.1.
Perfect. So we've got 53.2 on the bottom and on the top. So we're going to add those. And 23.1 is also on both sides. So we're just adding all the sides together.
Then you're going to get 152.6 inches.
Yeah, let's see. 2, 4, 5, 6. 3, 6, 9, 12, 5, 10, 11, 12, 13, 14, 15. 152.6 inches. Yes, ma'am. Okay, so that's our perimeter. Did anybody find the perimeter using a different method? Or did everybody just add all 4 sides? What did you do, Erica?
I did 53.2 times 2, then 23.1 times 2, and then added those 2 answers together.
Gotcha. So Erica decided to multiply each side that was given times 2 and then add those 2 larger numbers together. And of course, you got the same answer, so that's good. Perfect. Multiple ways to find perimeter. Okay, any questions on number 3? Everybody got them? Okay, so did anybody give the challenge a go? Number 4. Erica, you did? What did you decide to do to find the area and the perimeter here?
Well, the first thing I did is, I noticed this is a 30, 60, 90
Yes,
triangle.
it
I
is.
used the formula from last unit to find the length of the short side, which the side that is labeled as 10 inches is the 2x side. So that means to find the short side, I just have to take 10 inches divided by 2, which is 5.
Yes.
Okay, and then that will give me a base times height. And then from there, I just imagined this is a rectangle instead. So I did base times height, which gave me a total of 43.3. And then because this is essentially half of a rectangle, I used divided by 2 to find the area.
Yeah, that's incredible. Oh my gosh. Okay, you did that perfectly. That's amazing. I'm going to slow that down and tell everybody else what Erica just did because that was really good. That was really good. So, first of all, Erica, notice this is a 30, 60, 90 triangle, just like from our last unit. So she also noticed, I'm going to turn my picture to the side to show this. Remember in this triangle, that the longest side is 2x, the shortest side is x, and this is what, x radical 3, but we don't need to mess with that. Yeah, it's not important for this one. Because what we needed to do was find this missing side length so that we could find our area. So Erica saw, well, if 10 is 2x, then we can solve for x. So we did that first. And how would I solve for x? Divide by 2. Okay, and that would give me x is 5. So now we have our missing side length, 5 inches. So then what Erica did next, at least the way I am interpreting it, and correct me if I'm wrong, is she thought about how we would find the area of a rectangle. And let me grab like a sticky note or something here so that we can see it. A rectangle and a right triangle are related in a very specific way. Let me do this. And I'm going to kind of draw this triangle again. So we have, for example, here's my triangle. This triangle is exactly half of a rectangle. So what Erica did is she just found the area of what the rectangle version of this would be, and then thought, well, I don't need this part, and that's half of it, so why don't we just divide that number by 2? So this is the work that I'm assuming you did. You did 5 times 8.66? Okay, so I'll write that over here. 5 times, this is area, 8.66, and we basically divided that by 2. And let's see, 5 times 8.66, what does that give us? 43.3 divide by 2. It is a lot. I know. That's why I'm so impressed you figured it out. That's awesome. So we divide that by 2 and we get 21.65. Is that what you got? Perfect. Perfect. Okay, 21.65 inches squared. So the area was that base times height divided by 2 for a triangle. And we got 21.65 inches squared. Now, if you're following along right now and you're freaking out like, are we doing this next? No. I just wanted to give you a little challenge. It's okay if you didn't get this. We are going to be learning a few more different types of areas today, but I'm going to give us very thorough notes to make sure we can go back and reference our formulas. So don't worry yet. It will be okay. So we got our area. And then how did you find the perimeter?
It's just all the sides added up.
It's just all the sides added up. So that's our 5 inches, our 10 inches, and our 8.66 inches. So we just add all the sides. So let's see. 10 plus 5 plus 8.66. And I'm just going to bring down that 0.66. 8 plus 5 plus 0 is 13, yes. Carry my 1. 1 plus 1 is 2. Ooh, and this is a very rare case where the perimeter is larger than the area number. Normally your area is much bigger. But we got 23.66, and what's our units? Inches. Good. Okay, so that was a challenge. That was a challenge. That would be something that you might see as like a bonus question, maybe. She said nope. But, so there's that. I don't know. I think it's cool. I think it's really cool that you figured that out too. That's awesome. Did anybody else give that one a go or figure it out? Well, look at you. I love it. Okay, so what we're going to do now, we've done our do now, is I am going to pass out, thank you, not a worksheet, a handout with all of these different types of polygons, okay? And it's got the different numbers of sides, the names, and we're going to start talking about different types of polygons and how to find the area and perimeter of those. So I'm going to pause this, pass this out, and then we'll take a few notes. So we've done our do now, and we should all have that handout that looks like this, polygon names. So the word we are learning today is polygon. Everybody say polygon. Polygon. Yes, polygon. A polygon is just a fancy word for a closed shape. It is a closed shape. There are no openings. And I believe, I need to double check this, I believe polygons only can be made up of straight sides. So a circle, I don't think that's a polygon. I think that's its own thing. But we'll get into that later. So on polygons, we are going to learn specifically about something called a regular polygon. Regular polygons. So there's a difference between a general polygon and a regular polygon. A regular polygon has all sides the same length, all angles have the same measure. So we'll write that. I'm going to write here. Regular means all sides and angles are equal. All sides and angles are equal in regular polygons. And there's a certain way that we do label our sides and our angles and different parts of our polygons. So we're going to start with a triangle. On a triangle, we have three sides, and they are all the same length. I'm going to highlight my sides here. Okay. Wow, I'm kind of getting messy with that. Okay, so we have side, side, side. This could also be the base because it's on the bottom. So I'm going to write side slash base. But since it's a regular polygon, it doesn't really matter since they're all the same size. And then right down the middle of your triangle, we're going to have a line that goes straight up and down at a right angle. And this would be our height. So I'll zoom in a little so we can kind of see what we're doing at each part. Side, 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 slash base. And I'm going to write height. And over to the side here, I'm going to push it this way, and I'm going to write my area formula and my perimeter formula. So my area for a triangle is just base times height divided by 2, which Erica discovered for us today. Base times height divided by 2. And I'll write that out a little better here. Oh my goodness. I need this to be shining in a different spot. Okay. So that's base height. Base times height divided by 2. That's our area. Our perimeter is, we can say S plus S plus S for side, side, and side. Yes.
I think the base plus height, or base times height times 2 only works on right angle triangles. This one is not a right angle triangle. I think for this one, the area would be base divided by 2 times height.
Base divided by 2 times height.
Because if you take,
I'm curious. Let's do an example. Let's try it. Let's see what happens. Okay, so I love your observations. Okay, so what if I take a grid? Now you don't have to write this. We're doing an exploration for a moment. And I make, let's see, if I want it to be ISA. I think that's all the same. 1, 2, 3, 4, 5, 6. Well, let's see. 1, 2, 3, 4, 5. So 3, 5. What would that make this?
6.
Would it be 6?
Go from 1.2
Yes.
to 26.
it's an easier way to figure this out. If you cut a triangle out and then cut it in half along the height,
Yeah?
and then you take one side, flip it upside down, and put it on the other side of it, you'll get a rectangle. That's what I was saying. Base divided by 2 times height.
Oh, you're saying like if I slice this in half
Yeah.
and X that out, move it so that now it's here.
Yeah.
Okay, so I see what you mean. We have that. And then you're saying you would do base divided by 2
Times height.
times height.
Yeah.
Oh. Now, I believe you might still get the same answer, but let's try. Let's double check. So let's say the side was 6, and that would make the height. Gosh, I want to make sure I'm doing it right, though. I need a regular polygon. Okay, so that would mean this is 6, this is 3. I have to solve for x to find my height, because that's 3 and that's 6. So let's see. That would be a squared plus b squared is c squared. X squared plus 3 squared equals 6 squared. Guys, we're going on a tangent, but just bear with me.
Sorry.
No, don't be sorry. This is what we're here for. We're learning. Okay, so 9/36 x squared minus 9 minus 9. 36 minus 9. I can't do mental math. 27. Square root of that. 5.196, Okay, so that would mean my base is 6. My height is, we'll go with 5.196. And our question is, will I get the same answer if I do, let me make sure this is a little blurry. My question is, can I do base times height divided by 2 or base divided by 2 times height? Will that make a difference? So let's try that. Now I have my numbers. So first I'm going to try the way I just wrote. Area is 6 times 5.196 divided by 2. So let's try that. 6 times 5.196 divided by 2. And I got 15.588. So now let's try this way. Area is 6 divided by 2 times height, 5.196. So area is 3 times 5.196. I think so. You sure do. Area equals 15.588. So both ways work. Good. Awesome. So Erica, if this way makes more sense to you and what the reasoning that you're using, absolutely use it, because it will give you the right answer. Both ways will. So I appreciate you pointing that out, though. It's interesting. You would think it would give you something different, but that's why in the order of operations we have multiplication and division grouped together, because they can be done in any order, kind of, as long as there's not like addition mixed in. But anyway, if you zoned out during that, time to zone back in. We are back to regular instruction. So to find the area of a triangle, you would want to take the base times the height and divide by 2. To find the perimeter, we will do side plus side plus side. Or since they're all the same length, we could do 3 times the side length, because there's 3 sides. Okay. So that's for a triangle. Now, moving forward, I know that's a little bit of a glare right there. Moving forward to quadrilaterals. A regular quadrilateral, what is this shape always going to be called if all the sides are the same?
Square.
A square. A regular quadrilateral is a square. So, on a square, we have 4 sides. We have 1, 2, 3, 4. So side, side. It's all right. Let's go ahead and silence our phones. It's okay. Side. Now for area, how would we find the area of a square? Base times height. And since all the sides are the same length, I mean, really we're just doing a side times a side. Or we could say this is also the base and this is also the height. So for a quadrilateral or a square, area is base times height. And we also talked about earlier in the do now how since all sides are the same length, we could just do side times side, which is,
Side times 4.
oh, that would be perimeter.
Oh.
What is it when you take something times
Oh,
itself?
side times height.
Side times side would also be side squared, because it's a square. Makes sense? That's where squared comes from. When you're multiplying the same thing, it creates a square shape. So, two different ways to find area there. And perimeter, you just said it, Titania. How do you find the perimeter?
You take your side times 4.
Side times 4. So perimeter, 4 times whatever your side is. Now you're going to start to notice a pattern with perimeter. Triangle has 3 sides, so we do side times 3. Square has 4 sides, so we do side times 4. A pentagon has 5 sides. We're going to find the perimeter by doing the side length times 5. And it will continue just like that for all the others. So, I'm going to look here. A 5-sided shape now is called a pentagon because it has 5 sides that are all the same. 1, 2, 3, 4, 5. So the perimeter is 5 times the side length, because there's 5 of them. So side, 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 side. Now, as we go on to the rest of them, we're going to stop talking about area for a minute because I'm going to teach you something. So that's how we find the perimeter of a pentagon. Next we have a hexagon. That has 6 sides. How would I find the perimeter of that?
Side times 6.
The side length times 6. Because there's 6 sides. What about a heptagon? Heptagon. Go ahead.
Side times 7.
Side times 7. What about an octagon?
Side times 8.
Side times 8. What about a nonagon? Yep, times 9. And guys, it's going to go on like that forever. So really, we're taking the side length times however many sides there are. That continues. We could go ahead and fill out the rest of this if we wanted. 10 times side. Perimeter is 11 times the side length. 12 times the side length. Okay. Now, if we have a shape with a specific number of sides that is larger than 12, because now we have all the way up to 12, this is called a dodecagon. Crazy, some of these names. If we have more than 12 sides, I'm going to write this down here, more than 12 sides, we call it an n-gon, where we would replace n with however many sides it has. So if I had a shape with 98 sides, we would call it a 98-gon. Very creative. If we had a shape with 43 sides, it's a 43-gon. That's how we name them. So they kind of just gave up after 12, basically. So this is number of sides. Okay. I know, I'm throwing a lot of information at you guys. We're going to organize this today, don't worry. This is a lot for one little sheet of paper. We're kind of brainstorming this here. Okay. Do we have the basic idea here that perimeter is just the side length times however many sides? We can do that. Okay. So now I need to teach you a new word. And I'm going to have us write this on here. But again, we are going to organize this onto a separate note page here in a minute. This new word is called apothem. Apothem. This word is a word I never learned in high school. I was surprised to see it on here. I learned it the first time I taught this class. Apothem. Have any of you heard this word? Yeah, I hadn't either. So it's kind of cool though, because this word is going to give us the ability to find the area of any regular polygon, no matter how many sides it has. So I want everybody to say that after me. Apothem. 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 Good. Apothem. So an apothem is essentially this. I'm going to draw it. If I go to any of these shapes and I make a dot right in the middle, or as close to the middle as I can, the apothem is going to be the distance from the very middle of one side to the center. So this length is the apothem. Yes?
It's just going to turn the formula into a bunch of triangles, isn't it?
How do you know? How did you know that? Because yes, you're right. It is.
If you draw one to each one of the sides, they'll all be triangles.
Yes! Oh my gosh, you guys. Let me get a ruler because let's look at the theory of this. This is how mathematicians figured out how to find the area of things very quickly. If I draw lines through every single point on my hexagon here, here's what happens. I am going to take that goes to the center, and that, and here's that. Okay, and so what this apothem is, it's giving us the height of this little triangle here. So inside of a hexagon that is 6 sides, there are 1, 2, 3, 4, 5, 6 triangles. Do we see that? There's 6 triangles. And this is like the base of the triangle. The apothem is the height. So it's like we have base, we have height. And if I want to find the area, we could use that triangle area formula, base times height divided by 2, and take it times 6, because there's 6 of them. And that would give me my area. So, let's see. What we can do to sort of speed up the process, because you'll have to find the perimeter anyway, is there is a formula for the area of a regular polygon. And here is that formula. Area of regular, and I'm going to show you lots of examples because this is a little bit difficult to grasp sometimes. Area of regular polygons. It is the perimeter or basically that's all the side lengths added together, times the apothem divided by 2. So we've introduced all of these things, and if you're feeling overwhelmed, no need to fear. We're going to organize all of this into our notes, and we're going to practice using all of this today. I think sometimes this can feel overwhelming until you sit down and see it happening yourself and you're doing it yourself. So that is the area of a regular polygon. And at this point, I'm going to grab my notebook, and I would love for you all to grab your notebooks, and I want to show you at least one example before I give you a break. Let's see. My notebook. I'm going to pull this back. And I'm going to go ahead and title my notes just so that I don't lose track of them. I'm going to show you an example.
Is this still Unit 3 or Unit 4?
Still Unit 3, yes. So, geometry. Unit 3. And these are the day 12 notes. Page 1. And what we just talked a whole bunch about is regular polygons. So I'm going to write that again here. Regular polygons. Okay. And we'll write under here, all sides and angles are equal. Just like we did on that page. All sides and angles are equal. So we are going to draw, to the best of our ability, a hexagon. We're going to try. A hexagon has 6 sides, so do your very, very best. It's okay if it's not perfect, but here's how we're going to start it. I am going to give myself a line here, and then I'm going to kind of tilt down, like that. So we start with this shape, and then from there we're going to try to copy that, go down again, and here's that. There's my hexagon. That wasn't too bad. Okay, so I'm going to give you this hexagon where all the sides are the same. And here is how you will see the apothem labeled. You will have a point in the middle of your shape. There will be a line going like this somewhere on it, and you will always see the little box that says this is a right angle, a 90-degree angle. we'll get a side length. Like maybe I'll say this side is 5 inches. And then I'll say that my apothem is 7 inches. And I'll give everybody a minute to copy that down. I know this is a little tricky to draw, but just do your best. And as you're doing that, I'm going to just copy down again the area formula and the perimeter formula. Area equals, let's see, capital P means perimeter, then the lowercase a for apothem divided by 2. And then perimeter is N, which means number of sides, times whatever your side length is. Okay. So, let's see. Let's maybe start by finding the perimeter, because we'll need that perimeter to find the area. So if I want to use my perimeter formula, which is N times S, or the number of sides times my side length, first I need to figure out what is N, what is S. So in this problem, what is the number of sides? How many sides? 6. Good. And I don't think it's ever a bad idea to do this. I always tell people, as you count your sides, it's not a bad idea to mark the number you're on, because it is so easy to accidentally put one number too high or too low. So I'm going to say I've got 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. Okay, so I know my N is 6, and S, side length, what is that?
5 inches.
5 inches. So S is 5. So for perimeter, yes, how'd you get 30?
Take 5 times 6.
Perfect. N is 5, S is, oh, sorry, N is 6, S is 5. We're doing the number of sides times that side length, so 6 times 5, which is 30 inches. That's our perimeter. Okay. So I have my perimeter. Now before I move on to area, does anybody need another minute on perimeter? Is anybody still copying things down? Does anybody have questions about how we just got this? Everybody's okay on it? Okay, let's move to area then. Now we're going to use our area formula. How would we find area? Somebody raise your hand and tell me. Amanda.
You're gonna take 30
Mm-hmm.
and, wait a minute, I lost where I was. 30 and times it by 7.
Yes.
And then divide that by 2.
Perfect. So we need to take the perimeter, which we just found is 30, times the apothem, which is 7. So 30 times 7, and then we divide by 2. And let's see, I can actually type it in all at once if I want. 30 times 7 divided by 2. 105 inches squared. Good. Equals 105 inches squared. That's our area. Okay, so there's our first example. We've done it. We did it. All right. It is 10:24. I would like to give you guys a break. So let's take like 15 here. And when we come back, we'll do some more practice with this and talk about some other things. But let's say we come back by, what would 10:40 be, 15 minutes? Yeah, let's come back at around 10:40. And I will write that on a sticky note. And I will see you after break. Okay, so we are back from our break, and everybody should have this day 12 worksheet where we have about 20, I think it's, yes, 20 questions where each shape is a regular polygon and you are finding the perimeter and the area. So just like what we did in the do now, finding the perimeter and the area, we're just going to be applying the new formulas that I gave you. So we'll do number 4 as an example. Number 4 is going to be the example I show you. So if we're going to do the perimeter first, we're going to use that perimeter formula, which is, the perimeter is the number of sides times the side length. So N times S. So first I would count my sides. Let's see. I've got 1, 2, 3, 4, 5, 6, 7 sides. Okay, so I'm going to do 7 times. And what is my side length here? Yes, 14.1. That is my side. 14.1. So 7 times 14.1. Let's see what 7 times, so 287. Oh, I got a different number. I got 98.7. What did you type in?
Oh, 98.7, that's right.
Yes, perfect, perfect. Okay, so our perimeter for number 4 here would be 98.7, and they don't give us units on this worksheet, so we could either write inches squared if you want to assume, or you could say units squared. I'm going to write inches squared just because that's kind of what we're used to. And for the area, we're going to use that area formula where we have the area is the perimeter times the apothem divided by 2. And what is our apothem here? 14.7. That's the apothem. So we just found the perimeter. We're going to plug that in. Area equals perimeter. Guys, I made a mistake. What's our units for perimeter? Not inches squared. That's silly. Just inches. We're just measuring a length. Sorry, that is so my fault. Okay, so our area is that perimeter, 98.7 times the apothem, which is 14.7, and we just divide that by 2. So I'm just going to type that in all at once. 98.7 times 14.7 divided by 2. And I got 725.445. Did everybody get that same number, or did anybody get something different?
Can we round that up?
Yeah, you can round it if you would like, absolutely. So we could say 725.45, or we could just say 725.4. I'm not going to be picky on that though. But our area would be, let's write that down, 725.4. I'm going to go with 45. And this one would be inches squared. Good. Okay.
I know it's a crazy question.
No, go ahead.
The perimeter becomes the base, right?
The perimeter is all of those bases added together, because our side length here, like if I were to make a triangle, I have my side length is my base, 14.1, and my height is that apothem, the 14.7. And so basically what you're doing is base times height divided by 2 times n, or the number of sides. So the base times the number of sides would give us the perimeter. We could kind of think of the perimeter as like our giant base, because if I like stretch this out, it would become this super long stretched out thing with a bunch of triangles coming out of it, if that makes sense. But you could definitely kind of think of it as your base, and then the apothem is your height. Okay, so that is an example. That's number 4. Before I have you guys try a bunch of these on your own, does anybody want to see another example, or are we ready to just do it? Do another one? Okay, is there any of them on here that looks particularly difficult that you might want us to run through? Number 1? Yeah, let's do a triangle. Okay, so first we want to find the perimeter, and we know perimeter is going to be just the number of sides times the side length. So what is the number of sides here? 3. I have 1, 2, 3 sides. So my number of sides is 3. And what is my side length? For number 1.
38.1.
Yes, 38.1. This is our side length. And since these are regular polygons, all 3 sides are the same length. So that's why we're taking that number times the number of sides. So to find the perimeter, we're going to use that 3 times 38.1.
11.43.
11.43. Let's see, I'm going to type it in just to be certain.
114.
Ah, gotcha, 114. So 3 times 38.1 equals 114.3. Good. So P equals 114.3. And if we're saying that these are all inches, what would our units be for perimeter? Inches, not inches squared, because we're just finding a length here. So 114.3 inches. And it is super helpful if you circle your answers, because there's going to be a lot of numbers written out on this paper, and this will help kind of differentiate what is my answer and what's just my work. Okay, so we have a perimeter. How can we use that to find the area? Yes, Titania.
You take 114.3 times 11.
Times 11. Yes, divided by 2. So now we're going to use the area formula, which is perimeter times apothem divided by 2. And I just found my perimeter is 114.3. So I'll write that here. Perimeter 114.3. Our apothem right here is 11. So we're just plugging those in. You got about 628.65. Okay, let's see. I'm going to type it all in too. So 114.3 times 11 divided by 2. I got 628.65. Is that what you said you got?
Yeah.
Perfect. Okay, so the area is 628.65. Good. Inches squared. Perfect. Okay. Okay. All right. So hopefully those two examples helped a little. And I'm going to set a little timer, have you guys just work on these. Feel free to work together. I moved the tables so y'all can see each other and maybe work together a little more easily without having to kind of look behind you and stuff. So I'm going to set a timer like I said, and I will come around and check on everybody, see how we're all doing. And if you have any questions, let me know. Yes?
Since this worksheet doesn't actually have any units specified, is it fine if we don't?
If you don't put units, at least indicate that area is squared. That would be fine with me. In a quiz or something, I will give you units. I didn't notice this one didn't have units until I printed it, so that one's on me. All right, so I'm going to pause this, set a timer, I'll come around. Okay, so you guys just did a bunch of these on your own. Let's run through just a few of these and see if all our answers are matching up. So go ahead and flip back to the first page and let's look at number 2. Yes,
Can I roll it?
go ahead. What'd you get for perimeter?
I got 135.
135 even?
Yep.
Okay, did anybody get something different than 135 for number 2 for perimeter? Everybody got that? Okay, we're going to put inches in there.
Okay, so I took 135
Mhm.
times 13 divided by 2, and I got 877.5 inches squared.
Okay, 135 times 13 divided by 2, you got, say that again?
877.5.
877.5 inches squared. Okay, did anybody get something different? 877.5. We all got that? Good deal. Okay, that was number 2, 877.5 inches squared. Beautiful. Okay, let's look at number 3. Perimeter, what'd we get? 528.
About 52.
Oh, sorry. I misheard. My bad. 52.8. Do we all agree? Yes. So perimeter, we have our perimeter formula, which is a side length. Oh, hang on. I wrote it backwards. We have n for the number of sides times the side length. So first we want to see how many sides do we have. So we'll count 1, 2, 3, 4, 5, 6, 7, 8. So that means the number of sides here is 8. And we're going to look at the two given measures they give us. We have 8 and 6.6. Which one is our side length? 6.6. That is our side length. If it's outside of the shape, that's giving us a side length. When it's inside like this, that's our apothem. So we're going to take our side length, that is 6.6, and we're going to plug both of these values into our formula. Perimeter is the number of sides times a side. So 6.6 times 8, and I'll type it in. 6.6 times 8, and we get 52.8. Does that clarify it a little bit?
Yeah.
Good, 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 good. Okay, and if there were inches for units, we would call that inches. Okay. And what's the area here? Yes?
You'll take 6.6 times 8 divided by 2.
6.6 times 8.
Divided by 2.
Now is it 6.6 times 8? We want to use...
Oh, 52.
Ah, yes. So we're using the perimeter. Yes, yes, yes. 52.8 times the apothem, which is 8. And divide by 2. And what do we get? 211.2 inches squared. Did anybody get something different than that? 211.2 inches squared? Okay, I'm going to write that in then. 211.2 inches squared. Very good. Okay, and then we did number 4 earlier, so there's those. We got 98.7 for perimeter and 725.45 inches squared for area. Okay, can I go to the next page? Or does anybody still need to see this? Okay, moving forward. Moving forward. Number 5. Who can tell me the perimeter? Joe?
104.
104 inches. Did anybody get something different? Or did we all got 104? I love it. Awesome. 104 inches. We took 20.8, our side length, times what? 5. There's 5 sides. 1, 2, 3, 4, 5. 20.8 times 5 equals 104. Okay, and how do we get our area? Okay, we're going to take that perimeter, 104, times the apothem, 14.3, divide by 2, and what do we get?
743.6.
743.6. Everybody get that too? Okay, 743.6 inches squared. Good. Very good, very good. Okay, and then we're going to look at one more together. Number 6. What's my perimeter? You can
9.1
9.1
times
times
8.
times 8. 1, 2, 3, 4, 5, 6, 7. Yep, there's 8 sides. And what do we get? 72.8. Perfect. 72.8 inches. 72.8 times the apothem, that's 11, divided by 2, 400.4 inches squared. Okay, we get that? Yes, no, maybe?
I did round.
Okay, but you got pretty close to it. 36.4? That's a little different than 400. Let's see.
I got 400.4.
400.4.
Oh, I'm sorry. I think what I be messing up because sometimes I go from the perimeter with that answer and hurry up and put in times 11 divided by 2. They can give you the wrong answer.
Okay. So like you had your 72.8 in your calculator. Let's see.
So after I did 91.8, I
Mm-hmm.
mean 9.1 times 8.
Yes. Okay, so here.
72.
9.1 times 8. And you got your 72.8
And then I put times 11.
times 11
Divided by 2.
divided by 2. Huh. I wonder how yours...
Why my calculator gave me that?
That's interesting. Go type it one more time, just like that. It did it again.
No, it didn't give me the answer right here, but that is weird.
That is weird. So, okay, I want to mention something. You're not the first person that's had trouble with those smaller calculators. I know Rhonda was showing me the other day, anytime she would hit enter, it would square her answer. Like, even if that wasn't typed in. So, like, if she would have used that calculator, she would have got every question wrong, which is kind of wild. And really not fair to you guys because you're not going to get the right answers with a messed up calculator. So I may have to go through and double check all of those and make sure they work. And the other thing that I'm thinking about, I'm going to say starting tomorrow, because we're going to wrap up here soon. Starting tomorrow, I think we're going to pass out these yellow calculators, because how nice is it to be able to see what you typed? So much less stressful to guess if you typed it right or not. So we're going to switch to these calculators tomorrow. Or if you're not done with this worksheet yet, you can try this today. But now we have done 1 through 6 on here. We've got our perimeters and areas. Your exit ticket today is going to be to finish this worksheet. Okay? Finish the worksheet. If you have finished it already, turn it in and you're free to go. If you are not finished and you're a little nervous about your calculator now, feel free to use the yellow calculators. They are over by the computers, hanging up in little pouches. Just make sure you return them to the pouches when you are done. Yes?
I think for polygons that have 6 sides or less, the apothem will always be smaller than the sides.
Oh,
And
okay.
instead of larger, the apothem will always be larger.
I guess that makes sense. I'll have to... No problem. So you say if it's 6 sides or smaller, the apothem is
Smaller than each side.
smaller. I'm going to make a note of that. 6 sides are smaller.
These guys, it's battery low on here.
It's low battery. I have some extra batteries I can give you, or you can pick a different calculator. So 6 sides or less, apothem smaller. And then 7 sides or greater. Okay, I'm going to play with that and see if I can either prove or disprove it. And this one, the apothem would be bigger. That makes sense because the larger the shape, the shorter the sides must be,
Yeah.
and also the longer the apothem must be. Oh, that's interesting. I love the way that your brain works because you notice some really cool things.
And
Oh.
the smaller the angle between the apothem.
The smaller the angle between the, yeah. Oh, yeah, definitely. Especially because as we go, there's just more and more
Yeah.
apothems, and so they just,
Yeah.
yep, that's cool. That's really cool.
See you tomorrow.
See ya. Have a good day. I'm going to have to see if there's some sort of visual that exists that would show that, like the shrinking and growing of sides.
I'm really interested though that there's no proper polygon that the apothem is equal to the side.
Ooh.
7 is almost there, but not quite.
I wonder. I'm gonna do some research while you guys work on these. Apothem equal to
Sorry.
side? No, Erica, do not apologize. I actually love when you give me things to think about because I am also very much a math thinker. I love stuff like this.
I actually can't stand math, but
Well, you have the brain for it. Surprisingly, for someone who doesn't like it, you're really good at it.
I do numbers well.
Oh man. Okay, I'm gonna end this recording and post it.